Today we're going to look at the derivatives of inverse trigonometry, or inverse trig functions. So first, I just want to make sure you understand exactly what inverse trig functions are. I personally don't like the notation that they use with the negative ones, but let me back up. These do both mean the same thing. Sine to the negative 1 of x equals arcsine of x. Or this is the inverse sine. Both of those are the inverse of sine, the opposite of sine. Cosine to the negative 1 of x equals arc cosine of x, and so on. Those are all identical. I'm going to tend to use the arc sine and the arc cosine and the arc tangent. And the reason for that is normally negative 1 means 1 over that. So normally x to the negative 1 implies 1 over x. Okay, and that's true for most things. But sine to the negative 1 of x does not mean 1 over sine x. That's cosecant, and that's not the same thing. So like I said, personally, for that reason, I don't like that notation. I feel like the powers that be, whoever decided that originally, made a poor choice, but wasn't up to me. So anyway, just want to make sure it's very clear to you that both of those are the same thing. So while I'll be using mostly the arc sine, arc cosine, arc tangent, and so on, you should know that those are the same thing as sine to the negative 1, cosine to the negative 1, tangent to the negative 1, and so on. Alright, so first thing you need to know how to do is just plug these values in your calculators. This is just a little bit of inverse trig review in case you aren't aware of doing this before. So let me pull up the calculator and we'll move it over so we can see. Okay, so here I wrote sine to the negative 1 because that's how it's written in the calculator. So that's the same thing as arc sine of 1/2. And we get 0.5235, or I'll just round it to 0.523. You are allowed to just truncate on the AP test, so you could write 0.523 or 0.524. This is actually the same as pi over 6. Arc cosine of 0 gives you 1.571. That's the same as pi over 2. And arc tangent, or tan to the negative 1, of square root of 3. And we get 1.047. And that is the same as pi over 3. Now arc secant is a little different because we don't have an arc secant button in the calculator. We have arc sine, arc cosine, and arc tangent, but we do not have arc secant. So what you have to focus on here is what is the opposite of secant? Well, secant is 1 over cosine. So the way we plug this in our calculator is actually arc cosine of 1 over square root of 5 over 2. Now, some of you may be wondering, why don't we just do 1 over arc cosine? In other words, why don't we do this? Okay? Well, I'm going to show you that in a second, but let me just tell you that this is wrong. Okay, so we don't do this, we do this. So you do have to memorize what the opposites are. Sine is the same as 1 over cosecant. Cosine is the same as 1 over secant. Tangent is the same as 1 over cotangent. So that is important for you to remember so you know which ones are related to each other. So to figure out arc secant of square root of 5 over 2, I do secant cosine, or arc cosine, of 1 over parentheses square root of 5 over 2. And I get 0.463, or 0.464 if you want to round. Either way is fine. Now let me just briefly show you why that works out that way. You don't have to know this later on for a test or anything from me, but just so you're aware why that 1 over happens inside the parentheses instead of outside. So let's look at secant x as our example. Y equals secant of x. Okay, well we know that secant of x is the same thing as 1 over cosine x. And I'm going to go ahead and write it that way since we're trying to convert it to something we do have a button for. Because we do have buttons for sine, cosine, and tangent, but not for secant, cosecant, cotangent. Okay, if you remember, the way to find an inverse function, so that's what all these are, inverse trig functions, you reverse the x and the y. So I just switched where the x and the y were located. Now to find the inverse function, I need to solve for the y, get the y by itself. So I'm going to start by multiplying both sides by cosine y. That gets it out of the bottom. Divide both sides by x. And then to get rid of the cosine, get rid of this cosine, so y is by itself, I just do arc cosine of both sides. I think I have one too many c's there, sorry about that. So that gives us y equals arc cosine of 1 over x. So hopefully that shows you why we end up with the 1 over inside the parentheses. Again, as far as my class is concerned, you do not have to replicate that or be able to do that over again for me or show that. I just wanted to let you know why that works that way. To get some practice on there, you may want to turn to page 386 and do number 5 through 16. A few of them tell you to do it without a calculator. You don't need to worry about that. Just do them all in your calculator for the purposes of our course. Okay, if you want to pause and work on that, you certainly can. I'm going to put the answers up briefly so you can also pause and look at those if you want. Okay, the next thing we need to know how to do is solve for x when we have a trig function involved. So we're trying to get x by itself when we have arctangent involved. Well, to undo arctangent, or to get rid of the arctangent, we need to take the tangent of both sides, because they're inverses of each other. They do opposite things, so they cancel each other out. Okay, so tangent and arctangent cancel each other out. So that just leaves 2x minus 3 on the left side. Tangent of pi over 4 is equal to 1. So then simply add 3 to both sides and divide both sides by 2. So the key is just to remember that the opposite of arctangent is tangent. The opposite of cosine is arccosine. You can do that either way. To get rid of sine, you use arcsine. To get rid of arcsine, you use sine. Same idea as to get rid of a squared, you square root it. Or to get rid of a square root, you square it. You're just doing the opposite operations on these things to get rid of them or to cancel them out. Alright, so we're finally ready now for the derivatives. Now there are 6 inverse trig functions, so that means we have to have 6 inverse trig rules. And yes, you do need to memorize these. You must memorize them. I promise if you memorize these rules, the problems tend to be very simple. Having the rules in front of you will make these problems very simple. So memorize these rules. And really, if you notice, this right side right here, let me use my magic pen. Okay, this right side is actually the same as this left side, except for the sign. I think I said my left and my right backwards, I'm sorry. The first thing I circled is the same as the second thing I circled, just with a negative sign. So sine and cosine have the same rule, except that cosine's negative. Tangent and cotangent have the same rule, except that cotangent's negative. Secant and cosecant have the same rule, except cosecant's negative. So I would encourage you to write these somewhere if you haven't already, and to begin memorizing the rules. They're all fairly similar. du or u prime is actually the way our book writes it, but it's the same thing, is always on top. You notice there's always a u squared on the bottom. A couple things you can help remember that will help you remember these things. Sine and secant both have square roots. So the s's have square roots. Tangent, t kind of looks like a plus, and it's the only one that has plus in its rule. So that may help you, if you can at least memorize which 3 they are, that'll help you remember which one is which. So sine and secant have square roots. Tangent t looks like a plus sign. Okay, so first example, arced sine of 2x. And what I've done is just over to the right, I wrote out that rule to help us. So in this case, our u is right there. It's the 2x. So you use whatever's inside the trig function, or the inverse trig function. So if my u is 2x, my du would be 2. The derivative of 2x is 2. Then I do 1 minus 2x squared. Now I would not leave it like that. That answer is correct. It's just not simplified. So let's go ahead and simplify this. 2x squared is the same as 4x squared. And that would be my answer. So hopefully after we do a couple of these you'll agree with me that these really are simple as long as you know the rules. Okay, next up, arctangent of 3x. So let's say our u this time is 3x. Well, I have the rule right over here. It's the rule for arctangent. Du, the derivative of u in this case would be 3. And then 1 plus u squared, so 3x squared is the same as 3 over 1 plus 9x squared. And that would be my answer. Okay, third example, arc cosine of the square root of x. So this is the exact same rule as sine except for the negative part. So we just use the u, which in this case you can rewrite it if you want x to the 1/2. So the derivative is 1/2 x to the negative 1/2. This negative out front is just because that's the rule, to be negative. And then square root of 1 minus u squared, so square root of x squared. Alright, so there's lots of simplifying we can do here. First of all, square root of x squared is just x. And then I'm going to move the 2 from the 1/2 and the x to the negative 1/2 down to the bottom. So it becomes 2 square root of x square root of 1 minus x. That's okay to leave, or if you want, the two things in square roots can be combined, and you write it like that. So now all four of those answers are correct. The last two would be the most simplified, or honestly, probably the best two would be to leave it like that, or to go ahead all the way to here. But all four of those are equivalent, so they all are correct. Final example, arc secant of e to the 2x. Okay, secant and cosecant have the most complicated rule, just because it's got that extra absolute value. Now my u this time is e to the 2x, so my du is 2e to the 2x. 2e to the 2x. Absolute value of u, so absolute value of e to the 2x, square root of e to the 2x squared minus 1. Alright, now there's a couple things I can do to simplify this. First, in general, you cannot cancel things out that are inside absolute value with things that are not. And what I'm talking about is these two pieces right here. In general, that is not allowed. One's outside the absolute value, one's inside. You cannot cancel them out. However, e to the x, and therefore e to the 2x, is always positive, so you actually don't have to put the absolute value around that. So you can drop the absolute value sign, and then you can cancel those two out. On the inside here, e to the 2x squared is the same as e to the 4x minus 1. So we get 2 over the square root of e to the 4x minus 1. That would be our final answer. Alright, the homework I assigned this particular time was this. Anything in that range would be good practice. 31 and 32 are just solving for x. As an example, just like solving an equation, no derivative involved. 42 through 60 even are. Now some of those do require the chain rule or the product rule or the quotient rule, so do watch out for those.